In this video, we are going to talk about galvanic cells, which are also called voltaic cells. So, what are they? Galvanic or voltaic cells are devices that use a chemical reaction to create electricity. Specifically, the type of a chemical reaction that they use. It is called an oxidation-reduction reaction or a redox reaction, but we will talk more about that later. Now, galvanic or voltaic cells may be totally new terms for you, but I'm willing to bet that you use these devices almost every single day of your life, and that is because a battery is an example of a galvanic or voltaic cell. There are chemicals inside batteries, and those chemicals react together in an oxidation-reduction reaction that makes electricity, flashlight, or whatever the battery is hooked up to. So, let's learn more about these devices and see how a chemical reaction can create electricity. So, we have two beakers or containers of water, and into one of them we dissolve some zinc sulfate to make a solution, and in the other we dissolve some copper sulfate and make a solution. And then we take a piece of zinc metal like this one here and put it in zinc sulfate solution. And over here we put a copper metal in the copper sulfate solution. The next thing we do is we take a metal wire, and we use that to connect the two pieces of metal together. And when we do this, something amazing starts happening. Electrons start moving through this wire. They move from the zinc metal into the copper metal. Now, this is a big deal because moving electrons are what make electricity. And we could see that when we put a little light bulb here, it turns on because of electricity. And over here, we put the salt bridge that connects the two beakers. Let's understand what's causing electrons to move along this wire and create electricity.
A useful galvanic cell can be constructed by using zinc and copper. The anode is zinc bar placed into a zinc sulfate solution. And the cathode is copper bar placed into a copper sulfate solution. Okay, the two solutions are connected by a porous sodium chloride salt bridge that prevents the two solutions from mixing but allows ions to migrate. Attached Excel shows the electrons flow from zinc to copper because zinc is a more active metal than copper. It's more likely to lose electrons. For this reason, the zinc bar is oxidized, producing a zinc ion and 2 electrons per zinc atom. And the copper ions in solution gain 2 electrons and are reduced to copper metal. As the reaction continues, excess positive zinc ions build up in the zinc solutions. At the same time, the loss of copper ions from the copper sulfate solution creates the excess of negative sulfate ions. Positive sodium ions migrate into copper sulfate solution and salt bridge, while negative chloride ions migrate from the salt bridge to the zinc solutions and maintain neutrality of the solution. The reaction stops when the zinc bar or copper ions are depleted. The overall cell reaction can be written like this.
We have two half-of reactions, and we can put them together to get a net ionic equation, which shows the overall of oxidation and reduction process. Now, when we're talking about voltaic cell, we often represent them at a cell notation, which is a shorthand of abbreviation of the chemical reaction in a voltaic cell. It's a way that we can show what's going on without drawing a picture whole thing. Cell notation is sometimes referred to as a diagram.
What is the battery? Can you imagine a world where all electrical appliances had to be plugged in? Flashlights, cell phones, and toys would be tethered to electrical outlets, making them clumsy and inconvenient. Batteries provide portable, convenient sources of energy for powering devices without wires or cables. A dry cell is a common type of battery used today. It basically converts stored chemical energy into electrical energy. In the most basic terms, a battery cell is made up of three components: an anode, a cathode, and the electrolyte. In the dry cell, zinc is the anode, the graphite core is the cathode, and ammonium chloride base acts as an electrolyte. Due to chemical reaction within the battery, the anode builds up an excess of electrons. This is causes an electrical difference between the anode and the cathode. The electrons want to change themselves and display the extra electrons of the cathode. However, the electrolyte ensures the electrons can't travel directly to the cathode. When the circuit is closed, with help of conductive path between the anode and cathode, the electrons are able to travel to the cathode. This in turn provides power to any appliance placed along the way. Over time, this electrochemical process alters the chemical makeup in the anode and cathode, and eventually they stop providing electrons. And this is how a battery dies. Batteries provide us with a mobile source of power that makes many modern conveniences possible.